Alright, hello everyone. Today we're going to be focusing on amino acids and having a little look at what these look like, their formulas, and also some things you might be asked to do in the exam with amino acids. Alright, so let's get straight into an example. Alright, let's have a look here at this amino acid. This amino acid is actually alanine, so it's in your formula book. It's the first one in your formula book, so it's actually equals alanine. Okay, and it's one of the more simpler ones you'll find. So in your exam, you might also be asked to describe what is going on when a amino acid like this one here is placed into solution. It could either behave as an acid or as a base. Okay, so you can see in this molecule here, we kind of have two different parts. On the left, we have a amino group here. So this side is actually an amino part. The amino part comes from this side, and the acidic part comes from this side here. So this is a functional group for a carboxylic acid, and this is a functional group for an amine, hence the name amino acid. All right. So because of that, this amino acid can behave as an acid or as a base. All right. So you'll notice in the formula book, there's also something else called the pH of the isoelectric point. So what does that mean? An isoelectric point is a point where it is neither negative or positively charged. Okay, so this molecule here, this is actually not positive or not negatively charged because we have two hydrogens on this side and one hydrogen on this side. But this acidic side of the molecule, this can actually lose this hydrogen here. So it can lose this hydrogen and become CO minus, and that would make it negatively charged on this side. And also, the opposite can occur on this amine side as well. So this amine can actually gain another hydrogen and become more positively charged. So that's its basic side. Because remember, a base can accept hydrogen and an acid can give it away. So that's why it's got basic and acidic properties. All right, so let's see what happens if we put this molecule here in a solution at a pH of its isoelectric point. The isoelectric point for alanine is 6.1. So, alright, so what I've got here, I've got the same molecule. We have alanine, but this time it's actually in a different pH. So we put it in a solution, this time at a pH of 6.1, and this pH is the time that alanine becomes a Zwitter ion. So what is a Zwitter ion? What does it mean? Well, it means that this side becomes positive and this side becomes negative. So a Zwitter ion is so it's the amino acid that has an overall charge of 0, so it has a neutral charge. So at a pH of 6.1, it's going to be different for every amino acid, but for this one here, for alanine, at a pH of 6.1, the amino acid becomes a Zwitter ion. So what's going on? So this is equal to a Zwitter ion. And what's happening is this amino side has gained a hydrogen, and because hydrogen has a positive charge, when that hydrogen attaches to the left side of this amino acid, it becomes more positive. So it becomes more positively charged. And if we look at the other side too, this side here, the oxygen has given away one of these hydrogens here. So the hydrogen that was attached here has gone off, therefore making the right side of this amino acid more negatively charged. But it balances out, right? Because on this side, we have a positive charge, On this side, we have a negative charge. So overall, the entire molecule has come to a charge of 0, so it's still neutral. Alright? So, this is just kind of showing that amino acid can behave as a base and accept hydrogen, or it can behave as an acid and give away the hydrogen and become more negatively charged. Alright? So that's what a Zwitter ion is. So the definition of a Zwitter ion is the point at which, so it's a pH that a amino acid will have an overall charge of 0 or a neutral charge. So in the formula book, you'll see a table with the amino acids, and you'll also see next to it pH at isoelectric point or something like that. So the isoelectric point represents a pH that amino acid will become a Zwitter ion. For alanine, that was 6.1. So if we put alanine in a pH that is higher than 6.1, there will be less hydrogen in the solution, and therefore it'll become more acidic as it tries to give away that hydrogen. Right. So let's say we take this amino acid again and we put it in a solution that has a higher pH of 6.1. So let's say we put it in a solution that has a pH of around 8. So what's going to happen there, at a higher pH, there's less free hydrogen ions in solution. So because there's less free hydrogen, what's going to happen is that oxygen is going to stay negative because it's going to give away its hydrogen into the solution. But there's not enough hydrogens to become, for the amino acid to become NH3. So it's actually going to stay as NH2 on this side, and this is going to become negatively charged. So I'll draw that now so it makes a bit more sense. Alright, so this is what happens when we take alanine and we put it at a pH that is greater than 6.1. So if we put it in a solution that has a pH, say, of around 8 or 9, this is what the amino acid will look like. So at a higher pH, there is less hydrogen atoms available in solution. So if there's less hydrogen available, there's not going to be enough hydrogen to bond to this amino acid side here. So this, what was NH3 has now become NH2. So it's been depronated, which basically just means it's losing that hydrogen atom and becoming NH2, just like it is here. This other side is still going to be negatively charged because that acid side has given away the hydrogen and has given it to the solution, right? So it's left it and put it into the solution at a pH that is greater than 6.1. So this is what happens to an amino acid when it becomes, when the pH is above its isoelectric point. So here, the pH is above 6.1, and what's going to happen is we're going to stay negatively charged on the carboxylic acid part of the amino acid, but the amino end, or the amine end here, there isn't enough hydrogens in solution to be able to bond onto this side of the amino acid. So remember, at a higher pH, there is less free hydrogen atoms in solution. Alright, so that's covered in Unit 3. But if there's less hydrogen atoms in solution, then there isn't enough hydrogen to bond onto this amino side and create H3N or NH3. And instead, we have to give away the hydrogen from the acidic side, and this end becomes negatively charged. So an amino acid at a pH greater than its isoelectric point will have an overall negative charge. Alright, so I'll write that down here. Alanine, or any amino acid greater than its isoelectric point, will have an overall negative charge. Alright, let's have a look at alanine at a pH that is less than 6.1. Alright, so this is what happens when we put that same amino acid into a solution that has a lower pH than its isoelectric point. So for this case, for alanine, the pH is less than 6.1, which means that this molecule here is actually going to have an overall positive charge. The reason for that is because there is more hydrogen ions in solution, and therefore those hydrogen ions can bond to the amine side of the amino acid. So here we have NH3+. So because we have that extra hydrogen, it's positively charged on the left, and on this side here it's neutral because we don't need to give away this hydrogen. So overall, this amino acid has a positive charge. Alright, this is just a quick summary of everything we've gone through today. So a pH that is less than the isoelectric point equals a positively charged amino acid. If you put the pH lower than the isoelectric point, you will have an overall negatively charged amino acid. And if the pH is equal to the isoelectric point, that's when you'll have that neutral charged amino acid or the Zwitter ion. Okay? Alright, that's everything we'll go through for amino acids. If you have any questions, please let me know. Thanks.